So I will be explaining problem 5A right now on the expert TA, which is asking what is the minimum force needed to get the object moving. So the first thing that I did is that I found the formulas for the vertical and horizontal forces. So if we're going to add up the sums of the vertical forces, it would be force normal plus F1 sine theta minus mg, because if you look here at the free body diagram, the force normal is going up, the force 1 sine theta is also going up, and then the gravity is going downwards, which means that you subtract it because it's going the opposite direction. And then for the sum of the horizontal forces, it's F1 cosine theta minus force of friction, which is again like F1 cosine theta is going to the right, force of friction is going to the left, so it's going in the opposite direction, so it's getting subtracted. And for both of these forces, they're all equal to 0 because they're being set to equilibrium. And then a quick note about the cosine and sine. So those are the different components of gravity. So cosine is the cosine is because it's going horizontally, because cosine in SOHCAHTOA is adjacent over hypotenuse, which is going back to trigonometry. And then for sine, it's opposite over hypotenuse. So sine is meant to relate to the vertical component of gravity, and cosine is meant to relate to the horizontal component of gravity. Another formula before I get into my work is F1 cosine of theta is equal to mu times force normal. So this, if you're looking at the graph, you can see that F1 cosine of theta is going this way, and force normal times mu is like this. But when you multiply force normal times mu, which is mu is the coefficient to friction, you get force of friction, which is so it's equal to this. And so that's what I will be using for part of my equation during my work. So over here, I started out with saying that force normal equals mass times gravity minus sine theta F1, so times force 1. So then I set it equal to 0 because, like I said over there, it's the equilibrium of it. And so everything is meant to be equal because it's currently not moving. So I did 44, which is my mass, times 9.8, which is gravity, minus F1 sine of theta. And my theta here is 25 degrees, which is just given to you in the problem. And so then it's 0 equals 431.8 minus 4.4226 times force 1. And so this is where my F1 cosine of theta times mu times force equals mu times force normal comes in. So I set the equation up to equal F1 cosine of 25 equals 0.1, which is my coefficient for static friction, times 431.8 minus 0.4226 F1. So I set up this equation because it's asking for the minimum force needed to move the object, which means both horizontal and vertical force, including both the vertical and horizontal components. So that's why I set my equation up to include both the cosine and the sine, since I already found the force normal. And so then I get 0.9063 F equals 43.18 minus 0.04226 F, which is just by algebra. And so then I move I move the 0.04226 over to the left side, which gets me 0.9063 F plus 0.04226 F is equal to 43.18. And then I combine these two, so it gets 0.94856 F equals 43.18, and I divide. And so by doing that, I find that the force minimum needed to move the object is 45.5216 newtons. So this is the second part of the first video. This is problem 5B, which is asking to find the acceleration of the object once it starts moving. So the first thing I did was to set up an equation to find the net force, because I will later use that to find the acceleration. So to find the net force of this, it would be F net equals F cosine of theta minus the coefficient of kinetic friction, because now the object is moving. And then I plug back in what I found for force normal in my original equation, which is in 5A, which is 431.8 minus 0.4226. And so we set up that equation as a way to find all the net forces because it's the sum of them. So then I get F net equals F cosine of theta minus 0.03, which is my coefficient for kinetic friction, times 431.377, which is what you get from combining those two terms. And then you get F cosine of 25 minus 12.9413. And then you plug in for the variables that I found originally in the equation. So in 5a, I found that the force minimum to make something move was 45.5216. So I plugged that in for the force in front of cosine of theta. And then for theta, I plug in 25, which is given. And so I get 45.5216 times cosine of 25 minus 12.9413. And so F net equals 28.3153. And then to find the acceleration, acceleration is equal to F net divided by mass. So for me, it would be 28.3153 divided by 44. So the acceleration of the object when it starts to move is 0.6435 meters per second squared.